Today we are looking for the Z formal specification language, or we call as Z notation. Okay, pronounced as Z, ZED. This one is basically is English pronunciation of letter Z or Z. This one, please bear in mind, this one is not a programming languages. It's basically the to model the language that I have described in chapter 2. Chapter 2. Okay, and then what is the exact formal specification language? Is to describe the behavior of the system, is to model of the system in the language of modern mathematics. Okay, this one is very crucial points. And then it is a predominant foundation of modern mathematics used in Z is Zermelo-Fraenkel set theory. This one is dominant, dominant for the modern mathematics. It's called Zermelo-Fraenkel set theory. And then for the basic of Zermelo-Fraenkel set theory, okay, it's commonly abbreviated as ZF, or in some cases is ZFC, Zermelo-Fraenkel set theory. This one has been used to uh, to behavior specification, basically in a Z formal specification. And then it also underlies uh, every branch of mathematics, including the algebra, calculus, and discrete mathematics. Okay, I believe that discrete mathematics you have been get through. Okay, and then it also underlies all of modern physics and based on the seven core of axiom. Okay, axiom stated in the symbolic logic. Okay, later we see this one. What is symbolic logic? Okay, and then for the symbolic logic contains subject and predicates. This one you have learned in discrete math. For example, you have blue as a sky, long as a book, predicate. And then we have the logical negation, such as reptile are mammals, ocean are dry, and then you negate. Negate. Okay, this one is an example for symbolic logic. Okay, this one. Okay, for the symbolic logic. Okay, they have seven. 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 Okay, first one is we call it as a subject and predicate. Okay. Example, we have blue sky, and then we are also have a long for the books. Secondly, we have the logical negation. Logical negation, for example, reptiles are mammal. Mammals. M-A-M-M-A-L. Okay, we negate. Okay, for the negation, just for revision, you have learned in a discrete structure. Either you use this one or you use this one as a negation. Okay, you negate the statement. Okay, is it okay? Akif? Afiq, okay ke? Boleh? Buat catatan saya, do some simple notes. This one is not for me. I for me, my time is over. It is for you all. Okay, this one is logical negation. And number three, we have logical connective. Okay, logical connective. We have day, then we have disjunction night. Okay, disjunction. Okay, and then sorry, my handwriting is not so good. Hopefully you can understand. Okay, can I proceed? Okay, logical connective. Other example is speeding and chord implies ticket. Okay, and then we have quantifiers. Okay, quantifier you have learned in discrete math. For is quantifier. Quantifiers. Quantifier is to quantify. You have for all and existing. Okay, you have for all x. Okay, this one is a variable, and then you need statement water x implies freeze x. Okay, at the example, you can have existing x. Okay, rock x and large. Okay, please bear in mind, this one you have learned also in discrete math, discrete structure. You have a conjunction for existential uh, quantifier. For all, you need to have the implies. This one implies. Okay, this one for, and then you have okay, you have this one you have axiom, seven core of axiom. Okay, for example, you have extensionality, you have sum, you have set, you have regularity, you have infinity, you have cardinals, and then the last one is axiom of displacement. Okay, this one is for the basic Zermelo-Frankel set of theory. Okay, and then why we go by Z notation or Z expression. First one, it is expressive power. Expressive power. Okay, and then secondly is the to precise the formalism. Okay, because we want the formalism to be more precise and more accurate. Okay, and then number three is can be used to model a broad range of the system. Basically, this one for the complex system. Especially accuracy is very important and very crucial for safety critical system. Safety critical system that we learn in chapter one. For example, we have aeroplane, aerospace, and then we have heartbeat, heart monitoring system. Okay, and so on. Okay. Okay. So far, do you have any question? Is it okay? Clear? Yeah. Okay, this one is like a formal specification notation based on a set of theory. Set of theory, we have seven axiom that I have explained. Okay, and this one for the Z is being developed as programming research group, basically at Oxford in the late 1970s, and probably now is more widely used specification language. Okay, specification language basically to model the system behavior. Okay, and then international standard for Z notation is developed by using guidance of ISO. It's different from VDM. VDM is developed by SKI. This one is guidance. This one just for the guidance. Okay, for the schema is like a syntax. Syntax. Okay, you have A question mark as an input, A exclamation mark is for the output. This one output, this one input. Okay, and then we have A state of before operation. Okay, A tilde is component after operation. S is schema before operation. S tilde is state schema after operation. Later we see this one. And then we have delta. Okay, delta S. And then we have a Z symbol. Z symbol. This one we name it as a delta. Okay, delta mean that you change the state. You need to change the behavior of the state. And Z symbol is like what is constant. This one more or less like constant in programming. This one is like a variable. Okay, Joshua, okay ke baru datang? Joshua hilang dah. Ada tadi saya nampak. Joshua? Oh, mungkin line dia tak ni. Okay, this one is a video. Later you see in the My Guru. Okay, because okay, I have explained for this one. Okay, and then Z as specification language. Specification are built from the components called schema. Later we see what is schema. Okay, schema are the specification building block. We need to have the blocks. Okay, we need to have the block like this. Okay, later we see this one block. Okay, and then in Z specification also need a graphical representation to make the Z specification easier to understand and readable. It's more on the readable process. And then in Z also use the mathematical notation of schema that allows the building of a formal completeness and consistency. So to validate the specification, this one we need to validate. We can have the pre and post condition. Okay, we need to validate. Why? Because in schema we have the Boolean operation. Okay, okay, we also have the Boolean operation. Okay, and then after that we can also have the pre and post condition. Okay, and then introduce specification entities and define and defines the invariant predicates over this entity. Okay, we have learned invariant in VDM VDM SL last week over this entity, and then predicate is a Boolean expression. Okay, what is predicate? Predicate is Boolean expression. Okay, and then some predicate have side effect that change the state of the entity involved. Okay, side effect mean they have the pre and post condition that I explained before. They have a side effect that change the state. State. Okay, before that I have explained we have delta and z symbol like this. This one delta and z symbol. Okay, for delta the the values change. This one unchanged. Okay, and then schema can be included in the some other schema and maybe act as a type of definition. Okay, this one we have the accessor. Okay, we want to access another module. Okay, and then we have the uh, capsulation for another module. Okay, and names are local to schema. Okay, we have also have a global and local. In many respects, Z schema are akin to object. Okay, Z schema are akin to object, meaning it is simple to say that this one also is object-oriented approach, more on OO approach. Okay, for example here, a storage tank is monitored by a control system, and then the system consists of a container which holds something and a indicator panel which indicate or show the current field level and the danger level. Okay, we have the indicator that currently monitored for the storage. Okay, if the current field is above the standard level, and it will acknowledge system that it is a danger. And then if the storage tank does over the danger level, a warning light lighted on the indicator panel, and field operation must be specified as to ensure the tank to be refilled but never overfill. Okay, this one for the pre and post. Okay, this one pre, and then this one post condition. Okay, this one container. This one we name it as a container. Container for this one container schema. Container scheme. Because of container, because container is a universe of discourse. It's a domain. Okay, Rufinus, are you okay? Rufinus, boleh ke? Okay, and then we have a schema name container. Yeah, boleh ke? Ah, okay. Okay, and then we have N. We have the variable declaration signature declare the names and also the type entity produced in the schema. Okay, we have a variable declaration here, and then we have the predicates. Predicates. Okay, what is a predicate? Predicate is a statement. Statement that have truth values, either true or false. Okay, and then we have content is less than or equal to capacity, and then container we have delta because it changed. They have subscription here. Content is n, capacity is n. Okay, schema, natural numbers. Define the container which can hold discrete quantity of STH. The predicate define relationship between the entity in the by the signature by stating a logical expression. Okay, this one I've explained. Logical must be true. Must be true. This predicate state the obvious fact that the contents of the container cannot exceed its capacity. Okay, this one cannot be proceed the capacity. Capacity, let's say, is 1,000 liter. Cannot be exceed 1,000 liter. Azri, is that okay? Okay, sekejap 5 minit. Kita break 5 minit. Tiga. Ada. Ah, kita mengerti. Okay, we continue. Okay, we have a schema name. We have a schema signature that have the variable and declarations, and then we have a schema predicates. Schema predicates. The most effective way, a formal specification must be supplemented by supporting informal description. The exact schema presentation has been designed so it can be stand out from the surrounding text. Okay, this one is we need to have the container. Okay, the schema is given a meaningful name. You need to have the meaningful name for the schema, which is used to refer it to in other part of specification. Okay, and then the schema signature declares the names and types of entity produced in schema. Okay, it declares, it identify the types. Okay, and then in here we have uh, two state variables. Two state variables. These are we have a content and also we have capacity. Content and capacity, which are modeled as a natural numbers. N is for natural numbers. Okay, N is natural numbers. And natural numbers, what is natural numbers? Okay, it is just a recap. In discrete structure, you have learned this one, but never mind. I just recap. A natural number is an integer that is greater than or equal to zero. It is natural number. This partially define the container which can hold a discrete quantity of something. In here, we can say that it holds the quantity that are measurable, measurable, especially for the capacity. Okay, and then the schema predicates. Okay, we can see the schema predicate for the second one. Okay, define the relationship between the entity in the signature by stating a logical expression. Logical expression, for example, we have content is less than or equal to capacity. Please write down some notes. Boleh catat nota sikit ke? Nanti kamu lupa. Later on, you can refer back at your notes. This one is not meant for the lecturer. It's meant for you as a student. Okay, the schema predicate define the relationship again between the entity in the signature by stating and declaring or describing a logical expression which must always be true. Always must be true. It comes with the logical expression that always be true. Also, we call it as invariant. Invariant. Okay. And then the predicate state the obvious fact that the content of the container, basically in the schema name, cannot exceed the capacity, cannot exceed the measurable capacity. This specification says nothing about the size of the container or what the container is intended to hold. The definition of content and capacity as natural numbers stated that and describe that the container must hold a discrete amount of contents. Okay, this one is just I have explained this one. We have should be a name, signature, and predicate. A predicate that a part of defining a relationship between the entities by signature by stating a logical expression which must be always be true, also called as invariant. Fatin okey ke Fatin? Okay, this one is just three main important for the Z notation. Uh, for the invariant, which mean that never changing. For the mathematic function, quantity or property which remain unchanged when a specified transformation is applied. This one is for invariant. Invariant mean you have performed some operation in mathematics or logic, okay, that remain unchanged. Boleh baca ke tulisan saya? Can you read my handwritten? Boleh. Okay. Unchanged when specific operation or transformation is applied. Okay. Okay, this one is important lah. Remain unchanged. It is the definition of invariant. Okay. Okay, and then we have indicator specification here. We have an indicator container for the indicator. We have light off or on, and then we have reading. We define as natural numbers, and then for the third one is the schema predicates. Okay, predicate that part that defining the relationship. Okay, we have reading on is equal to reading greater than or equal to danger level. Okay, indicator schema introduce three entities. Symbol equal to biconditional or equal to can be read as if only if IFF. The predicate therefore specify the light should be on and if only if reading is less than or equal to danger level. That is low content warning is a signal or a sign. Okay. This one for the indicator specification. Okay, and then we have specification of a tank storage. Okay, container for tank storage tank. Given a specification of indicator and the container, okay, we have two here, one and two. Okay, they can be combined to define storage tank with capacity and indicator light. So the storage tank uh, combine the signature container and indicator in their predicates. Okay, it also has three other predicates. A predicate on spirit line means that they are separated by implicit and read as n and n. Okay, this one is very implicit. Implicit. You read reading content and capacity and danger level. Read if you read This one as a conjunction, conjunctive or conjunction, by and. Shawal, can you explain to me what is implicit mean? Boleh terangkan tak implicit tu apa dia? Hmm. Implicit ni maksudnya connected lah. Ada, kamu ni semua tak tahu ni. Kamu main game ke? Eh. Kamu tengok ke saya ngajar ni? Ya ke? Bukan boleh percaya kamu ni tak makan maruku ke? Okay, tengok this one is very important because in your final exam is quite challenging. Okay, and then implicit is connected when you want to connect the predicates, you need to have implicit and reading equal to content and capacity is equal to 25,000 and then the level is 25 200 and 245,000. The reading and content represent the same thing. Some redundancy. This result from the use of generalized schema building blocks. And in exact specification also include the facility for variable renaming, which could be removed this redundancy, but it's not covered in this topic. Okay, later I give you the ebooks. You should read. This one is very matured learning. You have to dig on the articles and journals to improve your understanding. Okay, this one is a specification of a storage tank. You can see a storage tank. They have a content as natural numbers, capacity, reading, danger level, and light, off or on. And then here they have the predicates. Okay, the predicates. Okay, okay. Basically, it is implicit, implicit or connected. Okay, we have a content is less than or equal capacity, and then light equal to on if and only if reading is greater than or equal to danger level. This one you can read as if and only if IFF. Yeah. Okay, and then reading equal to content. Okay, and then capacity to equal to 250,000 and danger level is 245,000. Okay. Okay, partial. We have a partial specification of field operation. Okay, partial mean that you have partially fill in the specification. It's not fully. Okay, field okay. We have another container. Okay, field okay is for the uh, container. Okay, we have a storage tank delta, which means that change the value changed, and then amount. Okay, this sign refer to pizza. Apa dia? What is the question? The question mark mean? Iza Nazira? Oh, Iza. Tak ada kan? Ama. Oh, Ama. Ni question mark ni untuk apa ni? Bukan. Mandai je kamu ni. Kamu tak makan lagi This one for input lah. Kan saya dah terangkan tadi. Uh, aduh. Macam mana Ama macam ni? Lepas tu we have here we have the predicate content plus amount as an input is less than or equal to capacity, and then content tilde is the post post after condition or after condition. Okay. We have content equal to content plus amount is after the content here. We go by post. Okay. Okay, this one is for partial specification. Okay, for partial specification, partial specification. Tak nampak eh? Ni partial baru nak ni lambat sikit. Internet ni kamu punya internet terlambat. Okay, we have a partial later on. Okay, later on I will explain it. Partial. Okay, for general, for partial is basically you need to have another functions. Huh? Okay, next is that convention. Convention means that it has naming convention. It has naming convention or syntax. Huh? Okay, and then here schema name prefixed by the Greek letter delta mean that operation change some or all of the state variable introduced by the schema. An input decorated with the question mark represent an input, and decorated with quote mark represent the value that state variable n after operation, or we call it as a post operation. Okay. Later in the final assessment or in the midterm, do not confuse. When I sometimes I use the post, sometimes I will use the uh, after operation. Okay, this one is just naming standard or naming convention. Okay, and then Z convention again. This one I have explained. Schema name prefixed by the Greek letter. We have a Z. Okay, the letter means that the defined operation does not change the value of the state variable. And input decorated with the exclamation mark as an output. This one is output. Okay. This one is input. Okay. You want to input into the schema. Okay. And then this one is just explanation for the partial field operation. The schema name is prefixed with delta. Okay, because you want to fill in the storage, indicating that operation change the state. This one is for the pre. And then the amount of added to tank is an input. You must have the amount, some amount as an input. Okay, and the predicate associated with the operation specify that the state is changed by the operation if the enough capacity of in the tank. And then the predicate field okay. Okay, specify the content completion after operation is equal to the sum. Okay, and then in addition, if the addition of the specified amount could cause the tank to overflow, and then the operation will not define. Okay, this one is for the predicate. Okay, we have overfill. This one also we have overfill partial. We have fill, and then if we combine together, it is full full specification. It's not partial. Okay, we have overfill. This one is delta, storage tank. This one is Z. Sorry, this one is Z, which means that the storage tank amount is fixed. It's not changed. Okay, and then we have amount and natural number, and then we have R as a input. Okay, and then capacity less than content plus amount is a input. Then R as a input in sufficient tank capacity, field cancel. Okay, and then after that we have another schema field okay or overfill. Okay, this one is a full specification. It's not it's combination of partial specification. Okay, we have a container. Okay, we have indicator. We have storage tank. We have field okay, overfill, and fill. Okay, we have six full problem specification. Okay, this one is to describe the full full partial. Okay, and then again for the partial function in Z are simply relation with the property that if they return a value, then the value is unique. Okay, for the full problem, it's not returning the value. If the partial, you need to return the value. Partial, you need to return the value. Okay, for example, container capacity content less than or equal to capacity. This one we uh, we return a capacity value. We return the capacity value. There is some debate that meaning of the application such a function to argument outside of their domain. Okay, and then semantic for partial application may be or may not be embedded to standard semantic for Z currently being developed. Okay, and then some of the semantic are undefined function application of the same type. Okay, you can use uh, partial to return the value, and you can use partial to assign undefined function. Partial you can use to undefined function. Okay. Okay, and then we have operation specification. Define the normal operation as a schema. Okay, define a schema for exceptional situation and operation may specify incrementally as separate schema. You have partial. Okay. And then the schema combine to produce the complete specification lah. And then combine all schema with disjunction or operator written in or lah. Okay, you must use the disjunction. Okay, because in here you can see the combination of all partial with used to have using the disjunction. Please bear in mind. Okay, we have a disjunction or all. Okay, and then Z notation includes name, signature, and predicate. Signature is introducing entities with their types. Okay, either natural number, rational number, and then we should have name that identify the schema. When you want to identify, you must use the meaningful function or meaningful name. And then the last one, predicate a part defining invariant over this entity. Okay, and then we have convention marks before schema, delta mean change, Z mean no change or unchanged. And then we have marks after state variable. We have a question mark for input and exclamation mark for output. And then represent the value of variable after operation. Okay, so far, do you have any question? Okay, punctuation marks. This one is okay. Represent the values after the operation for the post condition. Daniel, okay, Daniel. Okay, so far Kak Priya datang lambat Ada okay, nanti kamu tengok balik YouTube Saya upload dekat YouTube. Uh, okay, this one YouTube also I buy for you. 18 ringgit, 18 ringgit per month because I need extra features for YouTube Studio. Okay, thank you, thank you. Okay, and then here is symbols. We have S set of X, and then S is finite set. We have X is member, is not member. Okay, we have membership like this. It's not existential. This one is existential. This one is member. This one is not member. Okay, and then we have a subset. Okay, this one you have learned in discrete structure. You have a union, you have intersection, you have differences, you have empty set. Okay, you have a natural number, you have a integer number, you have a a real number. Okay, and then you have maximum number, minimum number, cardinality. Okay, the level. Okay. Okay, and then we have a symbol. Symbol f a partial function from x to y. We have partial like this. Partial mean you have a written value. Written value. To combine, you need this junction to combine the partial. Partial, and then f implies y is a total function. This one implies is a total function, and then DOM is domain for f and range. Okay, f, and then we have extensional function, extensional addition of mappings. We have mapping plus. Okay, and then we have a logic. Okay, we have negation, we have conjunction, disjunction, equivalences, implication, implies. Okay, equivalences also you can have like this. Equivalences. Okay, this one is for example. Later on, you need to do the assignment for VDM and ZAC specification. Please refer to my guru. If my guru cannot be open, I think I should upload to Padlet later on. Okay, specification for data dictionary. Example one. Okay, we have a data dictionary specification. Case system and used to keep track of system names. Okay, we have a structure, item name, description, and type. Type, assume this example allowed type those used in semantic data model, and then we have a creation date, and then we have operation. We have lookup, addition, replacing, and deletion of entities are formally specified. Okay, and then we have the this one is a partial function. And then operation for extracting and sorting all entities, relation or attribute entity has to be specified. Okay. Specified, you need to have a pre and post condition. Okay, given standard, this one is important because in the Z specification, you need input. Z does not require everything to be defined at specification time. And then some entity may be given and defined later. Defined later. Okay, and then the first stage in the specification process is to introduce this given sets. Okay, name and date. We don't care about the representation at this stage. It just give you uh, a basic information. Okay, and then we have a type of definition. Wait, okay, we have type definition. Uh, there are a number of built-in types such as integer, exact. We have float. Okay, we have characters. Okay, other types may be defined by enumeration. Enumeration, which means that they describe in the set. Okay. Okay, something that have relation, entity, and attribute. And schema as may also be used for type definition. The predicate serve as constraint on the type. We use the predicate to serve as a constraint for some invariant, some of invariants. Okay, and then we have a function, specification using function. For example, function is mapping from input value to output value. We have a small square, we have domain, small square, and then we have range. RNG is for range. This one is to specify the range of some of the set. Okay, for example, you can have a small square, okay, 149 and so on. Okay, and then we have data dictionary modeling. This one is basically is some sort like a partial function, partially function that we have add to make a new entry for a dictionary, replace existing entry, and then we have lookup. Okay, lookup is a given name, return a description, and then we have delete entry from the dictionary. We have replace the information associated with some of the entry that we describe as an input, and then extract some information. For example, if you have a books number, you want to extract a specific or search specific number, you can extract by sort all the names for the entry having a specific type. For example, if you have a type, for example, integer, integer can be extract. Integer type, you have character type, and so on. Okay, data entry. This one is data dictionary entry. Okay, schema name, and then we have name, description as a sequence character. We have type, same model type, and then we have creation date. And then you need also predicates. Description is less than or equal to 1,000. Okay. And then data dictionary as a function. We have a function here. You want to initialize the data dictionary. Okay, and then we have delta data dictionary, and then we have punctuation marks. DICT is equal to null. Okay, this one name. Name is partial for data dictionary because the name list is uh, not complete. Not complete, and then you have to return the value. Okay, and then operation we have add success, we have add failure. Add success is a change. Add failure is unchanged. Okay, please bear in mind for this one. Kecil sangat sangat saya besarkan sikit. Okay, this one is input. Oh, tak boleh tulis pula kalau ni. Okay, this one is input name in, name as input. Okay, that's data dictionary entry also input. And then for the predicate, we have name as input is not a member of a domain of data dictionary. And then data dictionary punctuation is post condition is equal to DDICT is union by the uh, set of a member of name, okay, implies entry as a input, okay. And then we have add failure. Okay, this one Z is unchanged. Okay, error name already in dictionary lah. Okay, we have a lookup operation. Okay, you can see this one later on. Okay, and then we have function overriding operator. In here also you have overriding operator. Replacing entry function uses the function overriding operator or written as uh, like exclusive or lah. Okay, we have phone. Okay, for example, we have set iron. The number is 3390, and then separated by comma ray 3392 and Steve. And then we have a domain of phone is iron, ray, and steel, and the range is like this. Okay, and then you have a new phone, you have phone, domain, new phone, Steve, and Ron. And then replace operation. Replace, you want to replace the data in the dictionary by the input of name and data dictionary entry lah. And then you have DDICT punctuation. It means the post condition is DDICT domain. Okay, from the name as input, and then this one is partial, partial entry. Okay, this one for deleting. Deleting for the entry, use the domain subtraction return which given a name. Remove that name we have here. Deleting the entry by using this symbol. Okay, for example, if you want to delete the iron, okay, 3390, you can have iron phone, and then it remain Ray and Steve. Remaining is for Ray and Steve. Okay, this one for delete. Delete, and then this one extracting entity of specific type. Okay, for all entry in DDICT data dictionary whose type in the type there is entry in the return. Okay, please bear in mind for the partial specification, you need to have the return value. The type of all member return in type, and then all members of return are members of range of data dictionary, and return is sorted by the name of the attribute. Attribute you need to sort. And then last one, you need to add lookup and delete. Okay, add lookup and delete by using this junction. This junction operation. Okay, this one we have add, lookup, and delete. You need to combine this one. Okay, so far do you have any question? Is it okay? I feel okay. Iza, okay girl? Okay, and then for birthday book, you need to take a look. For birthday book, same goes to library. We have Z schema that static and dynamic. Static mean it can occupy some of the data. Okay, it cannot be changed because it is invariant relationship constraint that are maintained and or the state that it value are changed are being changed. No? And then we have dynamic, the operation that are possible on the system state. The relationship between operation input and output and the change of the state happen during the application of the operation. Okay, in data dictionary modeling for the birthday, we have add, find, and remind. This one is for the birthday. Okay, add, make a new entry in the birthday book. Okay, and then find a given name and return. Okay, this one birthday book. Okay, initial state system, add operation, find operation, remind operation, and then we have specification completeness. Okay, this one is specification does to not take into account special state cases leading to errors. Okay, you want to add a new record for someone that already in the system. First, secondly, trying to find person unknown to the system. Okay, implementing such incomplete specification will probably lead to a broken system. And then there were three disadvantage of incomplete system implementation. First one, designer or programmer will have to invent their own solution. And secondly, system will might lose some of the data because of the inconsistency of the data. And third, a system might behave correctly, but giving warning to the user on the faulty inputs or giving meaningful messages on empty output. Okay, this one is the system on the system behavior. System behavior is not fully operated. Okay, to have the specification completeness, we develop a new schema accordingly to the special cases. Okay, and then combine new schema. Okay, and then for the advantage, provide the incremental and modular description of the specification, and specification are easier to be understand. Okay, specification completeness, for example, add extra output of result of type report to each operation. Okay, because the type operation is a free definition that define the operation status of the system. Okay, and then we have a report, and then we define the okay already known as not known. This one based on the three condition. One, two, three. Okay, this one completeness. We have success, already known, not known, and so on. Complete, complete operation. Okay, the key point of Z specification provide mathematical model of a system encompassing both static and also for the dynamic operation aspect. Okay, and then specification completeness is a key quality to achieve. Okay, you need to specify the complete specification. Okay, and then it must also be invariant. And then completeness can be achieved incrementally using a modular schema composition. Okay, this one you should have a meaningful. Okay, meaningful. And then incremental composition lead to more manageable and understandable specification. You need to decompose the predicates to have a more manageable and understandable specification. Okay, for example two, we have date. Okay, We have a date problem. Okay, for example, here we have different days in different months. We have leap year, we have year overflow, and so on. And then we have a radiation system, interlock system, example. Okay, please read this one. Interlock radiation system. Okay, and then we have initial state. Okay, enter room, and so on. Okay, again, this one is summarized. Start from informal description. You need to list out what is the requirements of your problem domain. Problem domain. Basically, we describe for domain of this course. And then define the required type. Okay, you need to define the required type. Okay, and then define the state variable. Define the relationship. Okay, define the initial state, define the operation, define the reasonable system, and consider extraction and combine. Combine, we use the disjunctive. Disjunctive. Okay, so far, do you have any question? Zuleha, okay ke? Akif, Afif, Daniel, Akif, boleh ke? Ho Izing, are you okay? Okay, I think that's all for today. Because for the for the assignment, I think you should look into my guru. Later I upload later of this day, and then please also upload into Padlet the notes of your uh,